Okay, this question we have complex equation here describing a circle. So z take 3 plus 4i, magnitude of that is equal to 2. So basically it's a circle with the centre here at 3 plus 4i and the radius is equal to 2. So first we want to find the maximum argument of z, the complex number z described by this circle here. And we can see that, I'll just fix that circle a bit so it's a bit more circular looking, around like that. We can see that the maximum argument of z will actually be a tangent to the circle here. So at this point right there, that'll be our maximum argument of z, this value around here. And the key is, I guess, when we want to find that argument, we can draw the circle, draw a line to the centre of the circle here, and if we form this right angle triangle, we'll notice that the tangent to the circle forms a right angle, and we've got a right angle triangle with the right angle in this position here. And what we can do is we can first of all work out this angle here, alpha. And we know first of all that we've got a radius of 2, and we can also find this hypotenuse of this triangle. So we've got 3 units, 4 units. We could use Pythagoras' theorem to find the hypotenuse. 3 squared plus 4 squared is 25, square root of 25 is 5, or in fact we've got a 3, 4, 5 Pythagorean triad. And that gives us enough information to find alpha here, and just using trig ratio, so that'll be our sine ratio, opposite over hypotenuse. We know that sine alpha is equal to opposite over hypotenuse, 2 over 5, and we can solve for alpha there. Where do we go here? So just bring up sine to the -1 of 2 divided by 5. So we get 0.41 radians for alpha. Now we actually want the maximum argument, which is all the way around here. So we also need to find this angle here. Let's call it gamma. And again, we can use this right angle triangle here. This time we'll use the tan ratio, opposite over adjacent. So we'll have tan of gamma is equal to 4 over 3, and that gives so tan to the -1 of 4 divided by 3, that gives 0.93 to 2 decimal places. So then we can see that the maximum value of argz will be equal to 0.41 plus 0.93, and that gives us a value of 1.34 to 2 decimal places as our maximum value for argz here. Now we also could find the minimum value of argz pretty easily, so part B. Now, z being any complex number described by this circle here, so our minimum value, similar to the maximum argument of z, will be the tangent on the underside of the circle over here, going through there, and then that tangent will make a right angle to the centre of the circle here again. Now my drawing's a little bit off here, but we've in fact got 2 congruent triangles here. We've got the radii the same size, we've got a common side, we've got right angles, so RHS, we've got 2 congruent triangles. So in actual fact, this angle in here, that one there, let's call it beta perhaps. Beta will be the same as alpha here, so we can just say straight up that tan beta is equal to 0.41. Of course, if you wanted to, you could have said that's just beta is equal to 4.1 there. We could have used the sine ratio, sine beta is equal to 2 over 5 to get that value of 0.41. And I guess there we're not after beta, we're after this argument here. So that's the minimum argument of z from there to there. And we'll notice in this case that that minimum value of argz will just be equal to gamma take away beta here. So we subtract that, we'll be left with this, this angle here. So it's just going to be gamma. I'll write down gamma, take beta. So gamma was equal to 0.93, take 0.41. Oh, I've just gone off the edge of the page there. There we go. So 0.93 take 0.41. And using our calculator there, we'll get 0.93 take away 0.41, just making sure we get the rounding correct. And we get to 2 decimal places 0.52 radians as that minimum argument of Z.